Jamb 2026 candidates, please get your pen and your notebook and let's start the lecture. We have some more to cover, so we have to be very, very fast. Let's go. Scalars versus vectors. Anywhere you see versus in my lecture, just know that we are comparing both. We are looking at the difference between both, okay? So the first we have here is scalar quantities. What are scalar quantities? They are quantities that have magnitudes only, but no direction. They have what? Magnitudes only, but no direction. What is magnitude? Magnitude is movement, motion. There is a motion, but there's no direction. Anywhere below is no direction. Let's look at the examples of scalar quantities. The first example we have here is mass. There's a movement, there's a force, but there's no direction. Time. Yes, there's a movement, some range of movement. There's magnitude, but no what? No direction. Temperature. There is a movement, there is a range of magnitude, but no direction. It does not have a direction. Then speed. There is a magnitude. There is movement, there is motion, but no direction. It's anywhere below face. The movement is non-directional, so it has no direction. Energy. There is what? Magnitude. There is force, but there is no what? There is no direction. It's non-directional. So the next we have here is vector quantities. And what are vector quantities? Vector quantities are the quantities or the physical quantities that have both magnitude and direction. So in vector, it has both what? Magnitude and direction. I already told you what magnitude is. I already told you what it means to have direction. Let's look at the examples of vector quantities. We have displacement. Displacement, there is magnitude, there is force, and there is direction. Remember, displacement is the distance covered in a specific direction. The next we have here is velocity. Velocity has magnitude and it also has direction. It's directional. The next is acceleration. And acceleration is measured in meter per second square. It has magnitude and it has direction. Acceleration, you are accelerating to a point. You are accelerating to a point. Speed is a scalar quantity. It has no direction. But acceleration is a vector quantity. It has both magnitude and direction. The next we have here is force, measured in Newton. And force has what? Direction, because it's applied on something. It's applied towards something. It has a direction. The next we have here is momentum. And you know what momentum is? Momentum is the product of a body's mass and its velocity. So mass times velocity makes up momentum. So there is a mass and a velocity. The velocity is the direction. The mass is the magnitude. That's it. Resultant of two vector or more vectors. So what is the meaning of resultant of two or more vectors? Let's look at it. Resultant of two or more vectors produces a single vector that has the same effect as two or more vectors acting together. So this single vector, which is the resultant vector, has the same effect of two or more vectors when acting together. That's why they say resultant of two or more vector. A vector having the same effect just like two or more vectors added or acting together. Then let's look at the method of determining the resultant of vectors. All these are what Jamb wants you to know. They want you to know all these. They want you to be good at this. The first method is parallelogram law. And the law states place two vectors T to T. Place two vectors T to T. Hope you are jotting down. Place two vectors what? T to T. Complete the parallelogram. The diagonal is the resultant. So when you place two vectors T to T, the diagonal is the what? The resultant. That's the resultant vector. So let's look at the next. The next we have here B, the next method. Triangle law. And how is the triangle law carried out? You place vectors head to T. Remember, the parallelogram is T to T. Now the triangle law is head to T. Then the closing side gives the resultant. The closing side does what? It gives the resultant. Unlike the parallelogram, where the diagonal is the resultant. But here in the triangle law, the closing side gives the resultant. Then the next method we have is the analytical method. That's the third method. And it states if two vectors A and B, that's for example A and B, act at an angle theta. You know that theta always represents angle. Then R is equal to open bracket A square plus B square plus 2AB cos theta. So this is the formula for using analytical method to calculate the resultant vector. This is the formula, okay? Just know that is resultant is equal to A bracket open A square plus B square plus 2AB cos theta. Theta is the angle. Direction, which is tan. If you want to calculate the direction, it's going to be tan, okay? The tan angle equal to B sin theta over A plus B cos theta. So this is the direction. If you want to calculate the direction, then this is the resultant vector. Relative velocity. What is relative velocity? When you hear anything relative, it means comparing two. Comparing one with another. That's the meaning of relative. So relative velocity here means comparing one velocity to another. Let's look at the definition. The definition says this is the velocity of one object as observed from another moving object. As observed from another moving object. So you are using the movement of this object to observe the movement of another object. So you are comparing the velocity of this object with that of another object, or you are measuring the velocity of an object with another object. So that's relative velocity, measuring the velocity of an object using or with the help of another object. And this here you have here is the relation, okay? A relative to B, that's you are measuring A relative to B equal to A, that's velocity for E, that's why you have this small v here, velocity for E minus B velocity or velocity for B. So that's it. The relation is what? How are you going to get the velocity of the object? Remember, one of the objects is serving as a standard velocity because you are using that object with standard velocity to measure the velocity of another object. It's just like you place two cars here. This one has a standard velocity of speed. Then you place another one here. You are using the velocity of this one that is ahead to measure the velocity of this one that is behind. So let's look at examples on the calculation of relative velocity. For example, two cars moving in opposite direction. So we now know that both cars are moving in opposite direction. Okay. So at 20 meter per second and 15 meter per second. So one of the car 20 meter per second, that's the velocity. The other is 15 meter per second. So how do you calculate the relative velocity? It's easy. Since they are moving opposite direction, if you want to calculate their relative velocity, you add both. Okay, you add both because you are told to calculate the relative velocity. You add both. Two cars moving in opposite direction at 20 meter per second and 15 meter per second. What is their relative velocity? The relative velocity, you add them up and you get the relative. Like I told you before, relative is adding two things together. Okay, adding them together. But when they are in the same direction, let's look at B. Two cars moving in the same direction as 25 meter per second and 20 meter per second. Okay, what is the relative velocity? So because they are on the same direction, you are going to minus. If they are in opposite direction, you plus. But the same direction, the car is moving towards the same direction, both of them the same direction, you minus. But if they are moving opposite direction, okay, like this, what do? You plus. Don't forget this rule of thumb. Resolution of vectors. What is resolution of vectors? It is splitting a vector into components along two perpendicular directions. You are splitting a vector into two components along two perpendicular directions. And what are these two perpendicular directions? S-axis and Y-axis. So if a vector arrow makes angle theta with the S-axis, R for S-axis, RS, that's why you are seeing RS here. R for S-axis is equal to arrow cos theta. If a vector arrow makes angle theta with the S-axis, we are going to use this formula. RS, that's for the S-axis, is equal to arrow cos theta. Very easy. That's the formula. Very easy. So you substitute arrow here, you put your angle here, then cos that angle is what? Times R. You get your answer. Resolution of vector. Same thing for the y-axis, but y-axis is sine, okay? Sine theta. Sine theta is used. So let's look at the graphical methods of vector problems. They include the parallelogram law. We just talked about that one, which states used to find resultants of two vectors not in the same line. So in what situation do you use the parallelogram to solve vector problems? You use it when there are two vectors in the same line. So the vectors must be on the same line for you to use the parallelogram law. Okay, remember, parallel, the same line, straight, parallel. So the next is the triangle law. And when is it used? It is used for successive vectors, okay, head to tail, like we said before, while the polygon law is used for multiple vectors. They form a closed polygon. Resultant equal. I must repeat questions. Question 1. Which of the following is a vector quantity? A. Speed. B. Mass. C. Velocity. D. Temperature. What's the answer? Drop the answer in the comment section. Question 2. Two forces of 6 Newton and 8 Newton act at right angles to each other. What is their resultant? A. 10 Newton. B. 12 Newton. C. 14 Newton. D. 2 Newton. Drop the answer in the comment section. Question 3. A car moves east at 25 meters per second while another moves west at 15 meters per second. The velocity of the first car relative to the second is A. 10 meters per second, B. 40 meters per second, C. 25 meters per second, D. 15 meters per second. Drop the answer in the comment section. Question 4. A force of 50 Newton acts at an angle of 30 degrees to the horizontal. Its horizontal component is A. 25 Newton, C. 50 Newton, D. 12.5 Newton. Drop the answer in the comment section. Question 5. Which law of vector addition states that if two vectors are represented in magnitude and direction by two adjacent sides of a parallelogram, then their resultant is given by diagonal? A. Triangle law, B. Parallelogram law, C. Polygon law, D. Lami's theorem. Drop the answer in the comments.